This lecture will talk about Apache Kafka. So before we begin talking about Apache Kafka, I would like to introduce you to some concepts which are very essential to it, which is message queue. What are these and what are their importance in modern platforms? So message queue is a form of an asynchronous service-to-service communication used in serverless and microservice architecture. Messages are stored on a queue until they are processed and deleted. Each message is processed only once by a single consumer. Message queue can be used to decouple heavyweight processing to buffer or batch work and to smooth spiky workload. Let me give you an example. For example, you are working with your friend and you are doing maybe building bunch of envelope, and one friend job is to fold the envelope and another friend job is to stick the envelope with some kind of a gum. And what happens if your friend who is actually folding the envelope, he produces much more faster envelopes that he can produce that you can stitch it. So what will happen? The number of pile up of tasks that you have to stick together, it keeps growing, and that is what called is a overloading. In that condition situation, assume for some reason if you are not able to handle the incoming request, you may end up dropping some of the envelope, or maybe you will lose some envelope. Similar concept applies to the data as well. Assume you have a web service which is producing data extremely fast, and the consumer which is supposed to process that data and possibly create some kind of order, and if it is not able to do that, you may end up having some kind of a latency issue, or maybe some of the messages will be lost. In order to solve these problems, you always need some kind of a buffering mechanism by message queues, and all modern message queues supports in that way. So message queue provides communication coordination for these distributed applications. Message queues can significantly simplify coding of decoupling application while improving performance, reliability, and scalability. Let's take a look into this diagram. This diagram shows a data flow. From the left side, it is a data producer which is creating files, and it is the buffer that you see, it is the message queue which will store the data till consumer has consumed all the data, and it creates a very well designed distributed data system. In that way, producer can no longer worry whether my consumer is fast enough or not. It can just keep pumping data, and whenever the consumer is ready, it will consume the data and be sure that no data has been lost. And most message queue also support order of the delivery. It means the way the order it was sent, same order it will be received. Now let's talk about Apache Kafka. What is Apache Kafka? Apache Kafka is a modern form of a message queue, or rather named as a distributed streaming platform. Apache Kafka came out of LinkedIn as a part of their notification system as a commit log. So, over a period of time, Apache Kafka has grown up into a completely distributed platform which can scale horizontally. And what is horizontal scalability and vertical scalability? We have already discussed in the distributed computing system. So, Apache Kafka is a publish and subscribe system to the stream of records. Store streams of records in a fault tolerant way. It means due to any reason, if any of the node failure happens, Apache Kafka will be fully able to recover the nodes and there will be no data loss. Process stream of record as they occur. This diagram shows how Apache Kafka cluster works. Producer, they produce data, publish data into the Kafka cluster, and consumer application will be subscribed to the topic, and the the data could be consumed directly by the application or via third party connector could be sent to a database as well. So Apache Kafka runs as a cluster or one or more server. It means at any time In a production kind scenario, it is expected that you will have more than one Apache Kafka cluster. Usually recommended numbers are either 3 or 5. It is good to have odd number so that during the voting process, it can always choose a leader. The Kafka cluster stores stream of records in a categories called topics, and each record consists of a key, a value, and a timestamp. So this diagram shows the anatomy of topics and how these are managed. And in Apache Kafka term, each time you push the message, they are called as a commit log because it is because of the history of Apache Kafka how it evolved. It evolved from a commit log data. So give you some kind of example. What happens? Topics are the logical segregation of data streams where a consumer and producer can subscribe to. For example, the nearest example I can take of, assume a Twitter hashtag. If you are following a Twitter hashtag, say for example, weather, if you are subscribed to that particular hashtag, you will get all the notification or messages related to the message hashtag. And if I try to map it in a Kafka concept, it is a topic. So anybody want to push any data into Twitter, for example, on a weather hashtag, they will use that hashtag and publish the data. Anybody is subscribed to that channel, they will receive the data. This is the very fundamental concepts about topics. And of course, more advanced topic about how the segment of the data is created, how consumer groups are created. These are more advanced concept where you actually use Apache Kafka as a developing some kind of application. Because in this lecture, we are looking only for the fundamental concept and introduction. So I will rest here. I hope you enjoyed the lecture.